And welcome to a new video. In this video, we're going to talk about multi-dimensional arrays, and we're going to talk about sort and search algorithms. I'm going to start with the search and sort algorithms, and let's start with the search algorithms. Now, as I said before, programming, we don't learn programming for the purpose of programming. We learn programming so we can process data. That's one of the main reasons why we actually have programs. So one of the main operation or the basic operations that we would like to do whenever you have a set of data is to search. For example, I have a long list of students, and let's say I have 50 or 60 students in my class, and I would like to know how many of those 60 class students actually passed the course. So I need to search for those who passed the course. That's a search operation. Let's say I got an email from my dean asking me about a specific student. So I do have a long list of students, and they're all stored inside a data structure or a database. Now, if I want to pull the information of that student, I need to search for that student using his ID number, for example. So search is one of the main and basic operations that we apply to data structures in general. Now, since the only data structure we talked about in this course is arrays, so mainly we're going to be searching an array. What I'm going to do today, I'm going to demonstrate the process, which basically is very simple. Let me just open Paint here. And I want you to imagine that I do have the following numbers. So if I told you, like, search for the value 2 in this array, this is how you usually do. Now, your eyes is doing it without even knowing that it's doing it. You're going to compare 2 with the first value, and the second value, and the third value, and the fourth value, and then you found a match at the fifth value. What are you going to do? You're going to tell me that I did found 2 at the fifth value is the number that you're looking for. And if I want to use the indexes to indicate the location of that number, so this is going to be 0, 1, 2, 3, and 4. So you're going to tell me it does exist at 4. And that's basically how you do. Your eyes actually is doing it by scanning those numbers and telling me. Now, since I just have 5 numbers here, it was easy for me to find it. But if I give you millions of numbers here and I ask you to look for one, your eye will not be able to find that number. So what you're going to do, you're going to go one by one, searching until you find the number you're looking for. And so that's basically how do we do searching in general. Now, what if I'm looking for the value 10? Well, in this case, there is no 10, so you need to find a way to tell me that 10 doesn't exist. Back to Visual Studio now, and let's imagine we have an array. In this array, I'm going to call it AAR. I'm going to put, let's say, 10 elements in this array, and let's just go ahead and put them randomly. I'm going to make sure that no duplication. There's duplication here. Well, you know what? Let me just put a duplication here just for the purpose of it. Now let's count how many we got. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that was okay. So I got the numbers now. I got the array. Now my job is to search for an element inside the array. What I'm going to do, I'm going to use a function to get this job done. And I'm going to create the function in this area, and this function is going to return an index, which basically the element, the location of the element that I'm looking for. I'm going to call it search. And in this search function, I'm going to pass an array. And I'm going to pass the value that I'm looking for. Okay, so I am going to pass the array to the function, and I'm also going to pass the value that I'm looking for into this function. And if I'm going to come here and create an integer index, and I'm going to set it to equal search, I'm going to pass AAR, which is my array, and I'm going to pass, let's say, 3. This is the value that I'm looking for. Now, from a look, you should know that 3 is here, so it should return 0, 1, 2, 3, 4, 5. So 5 should be returned. Now, here's how it works. What I'm going to do, I'm going to come at the beginning and create a variable. I'm going to call it index or end, and I'm going to set it to -1. Now, you may ask, why -1? Because I'm going to search for the element that I'm looking for in this area here. And at the bottom here, I'm going to say return end. So when I'm going to be doing the the search for the element, if I found it, then whenever I'm going to find it, I'm going to return the index. But if I finished the search and I couldn't find any value match the value that I'm looking for here, basically return end, which basically the value that end has is -1. So let's just go ahead and show you how is that going to work. The idea is very simple. You need to scan the elements one by one. So I'm going to have a for loop, and this time integer I equals 0, I is less than size, which basically represent the size of the array, and I plus plus. What I'm going to do here, I'm going to make it easier for myself, and I'm going to pass the size, which is 10. Now, I started to make unacceptable mistakes here. So what I'm going to do, I'm going to fix them. Constant integer size equal 10. And I'm going to put size here. I'm going to pass size here. And I'm going to receive size here. Okay, so now size is defined. That should fix the problem. Okay, so here, this is the area where we're going to play. So what I'm going to do, I'm going to say if the value, the element at index 0 at the beginning, or I, whatever I is, equal val. That basically means if you find a match, here's what I want you to do. End will equal I, which basically is the element at that position, the index of that position, and return, well, I will keep this here for now. I'll just change the value, and I'll show you some tricks with this example here. So let's have a look here. When I'm going to come here, I'm going to say if index equal -1, that basically means cout value could not be found. Now, let me just put \n. It's more efficient that way. Else, and let me just copy this, and I will say value was found at index, and then after that I will put the value of index, and then end line semicolon, and stick that extra semicolon here out. Okay, so how is this going to work? What I'm going to do now, I'm going to change 3 to be 100. And obviously I can see here there was no 100 here. So what's going to happen, we're going to go past the array here, the value 100 here, and the size, which is 10 here. I started by initializing the end value with a -1, and now I'm going to scan my array one element by element. So I'm going to compare the 7 that I have here with the 100. If I found a match, index is going to be updated. Otherwise, I'm going to keep going. As you can see here, since there is no 100 here, this condition would never be true. So the last value that index has was -1, and that's what's going to be returned. So when index is going to be returned here as -1, I'm going to check and see if index equals -1. That basically means the value could not be found. Otherwise, it would be found. Let's just run it for now to make sure that we got this case covered. And value could not be found. Now what I'm going to do, I'm going to change this to be 3. And now as you can see here, as it says 0, 1, 2, 3, 4, 5. So I'm supposed to get 5. Value was found at index 5. Okay, now the question is, what if I put 9 here? And I want you to pay attention here. I do have 2 9s here. So which one of them is going to be returned? The index of this 9 or the index of this 9? Well, it depends on what you have here. As you can see here, I will find a match when I get to index or I equal 1. So at that point, index is going to be updated to be 1. But later on, I will find another index at 0, 1, 2, 3, 4, 5, 6, 7. So when I find another match, index is going to be updated to be 7. So 7 is going to be returned. And let me just run it. And here we go, index 7. So what I'm trying to say here, this function here will return the index of the last appearance of the number that you're looking for. The question is, what if I'm looking for the first appearance? Well, the idea here is very simple. Return index. Or in this, if that's the case, you don't need this anymore. You can just say return I. And since I want you to know both of them, I'm going to put index equal I here as an indication that you have those two cases. Now if I run it, you'll notice that it's going to be 1, not 7 as before. This is how simple search is. And we do have another search. It's called binary search, but it's not mentioned here, and you guys are going to be dealing with it. Binary search, basically, I'm just going to explain it here really quick. To be able to use binary search, you need this array to be sorted from the smallest value to the greatest value, or the greatest value to the smallest value, but we just got to go with the smallest value to the greatest value. Now, before we get to the binary search, let me just ask you a question. What if I'm looking for the value 10? What does that mean? That basically means I'm going to have to go through this for loop all the way to the end to find the value I'm looking for. What if I have 1,000,000 elements? So basically means I have to scan 1,000,000 elements. What if the element that I'm looking for doesn't exist? Then again, I have to scan 1,000,000 elements. This is considered as a little bit inefficient algorithm. Now, if this algorithm if those data were actually sorted, I'm just going to imagine they were sorted. So I'll just go 1, 2, 3, 4. What else do we have here? We have 7, we have 8, we have 9, we have 9, and we have 10. Let me just count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, what do I miss here? There's a 12th. So here we go. This is sorted. Now, the binary search basically means you jump into the middle and you compare the value that you're looking for with the one in the middle. For example, if I'm looking for the value 3 here in this case, I go to 8 and compare 8 to 3, and I found out that, well, there is no match. What is that telling me? Since this data is already sorted, that basically means the element that I'm looking for will be in this area. So there is no need for me to check this area. So by a simple comparison here with the one in the middle, I was able to eliminate half of the size of the data. And then after that, I went to 3 in the middle of this data structure here that I have, this array, subarray, if you will. And I compare with the 3. Oh, here we go, it's match. So out of 2 comparisons, I was able to find the match that I was looking for. This is a binary search algorithm. Now, if I want to apply the same concept here, I need to check 1, 2, 3, 4, 5, 6 until I found 3. Here, just 2 comparisons. So that's basically what binary search. Again, you don't have to worry about that. If you don't like it, just let it go. Okay, so this is search algorithms. Let's move on and start talking about sorting algorithms. As I said in the binary search, this has to be sorted for it to work. So what I'm going to do, I'm going to talk about sorting algorithms. We're going to talk about the selection sort algorithm, and then after that, we're going to talk about the bubble sort algorithm. So let's start with the selection sort. I'm going to try to sort this array using the selection sort algorithm. So here's what I'm going to do. I'm going to say selection sort, and I'm going to do the same thing. I'm going to pass the array, and I'm going to pass the size. That's all I need here. And let's go ahead and create that function. So void, let me copy this. And then integer AAR, and then integer size. Now this is not going to be very easy, but let's have another method to print the array before and after. So I'm going to come here in this area and say void print array. And again, I'm going to copy those. I'm going to put it here. And this is a simple for loop. You know what? I am lazy. So I'm going to copy this. Oops. Copy this. Put it here. And then in this area, I'm just going to get cout AAR or ARR of I. And then I will have a space between them, semicolon, and here we go, cout and line. So this is my, so here I'm going to go and say cout before semicolon, and I'm going to call the function print array pass AAR and pass size semicolon. And I'm going to do the same thing here, copy this, put it here, and I'm going to say after. So I got before and after. Of course, the body of the selection sort is empty, so nothing's going to happen. I'm just going to show you that I'll get the same array to be printed exactly the same. And here's what I'm going to do. I'm going to put an extra space. Let's put it before and after. And I'm going to put an extra space here so they will look kind of good. Okay. So how does this selection sort algorithm works? The idea is very simple. And let me go back to the paint. Control N, don't save, increase the font. I'm going to make it a very, very simple example here. Let's say you got 3, got 4, got 1, I got 5, and I got 2. So I got those 5 values. The idea here is to, starting from the first element here, you go all the way to the end, searching for the smallest value. And every time you find a value that's smaller than 3, you store it as the mini value. So I'm going to go mini. So 3 and 4, no, 4 is not smaller than 3. Then 1 and 3, yes, 1 is smaller than 3. So we got smaller 1 here. Let me put 0 here so you'll understand what I'm saying here. And then I go 5. 5 is not smaller than mini. 2 is not smaller than mini. And then, 0 is smaller than mini. So we update the mini to be 0. So now I know that the smaller value is 0, and it's at index of 0, 1, 2, 3, 4, 5. So what I'm going to do, I'm going to take the 3 and swap it with the 0. And as a result of that, let's just draw the 0 back here again. As a result of this swapping, basically 3 will be moved here. And then let's wipe this. And 0 will be stored here. Right after that, you move on to the next value. Now, by the end of this operation, the smaller value will be stored here. Right after that, you move on to the next value, which is 4. You keep your eye on 4 and you look for the smallest value. Compare 1 with 4. Yeah, now 1 is the smallest value. And then you go to 5. 5 is not smaller than 1. 2 is not smaller than 1. And 3 is not smaller than 1. And after that, you're just going to have to swap the 4 with the 1. And that's basically will lead to, this will be 1. And this will be 4. And that's an ugly 4. This is another ugly 1. So let's just go ahead and fix that. What is this? Okay. And here we go. Right after that, you move to the next value, which is 4 in this case. You compare with 5. 5 is not smaller. 2 is smaller, so the mini value is going to be 2. You always assume that the element you're currently is the smallest value. So this mini value is going to be updated with 2. And then you move on. Well, 3 is not smaller than, so the minimum value was 2. And you have to swap 2 with 4. And as a result of that, you will end up having 2 here. And 4 will be moved here. And you keep going that way until you get the data sort. So this is the idea of selection sort. Now, how do I perform that in a program? Well, the idea here is very simple. What I'm going to do, I'm going to start by creating two variables. I'm going to call the first one mini. I'll set that to 0. And then another integer, I'm going to call it mini index. And I'll set that to 0 as well at the beginning. So I need to have two for loops. The first for loop here, and then I'll have another for loop. Now, the first for loop is going to start from index, let's say I equals 0, I is less than size, which basically I'm going to have to think about that in a sec, then I plus plus. Now this needs to be size minus 1. You may ask, why size minus 1? Because right after you get to the last element, there is no elements after that, so you're going to have to stop at that point. Well, let's just keep going now, and we'll see if this assumption is right. And this one, this is very important. This is index, let's say j. J is going to equal I plus 1. And then j less than size, and then j plus plus. Now you may ask the question again, why is j plus 1? I want you to think about this again, but in this form. When I started with the first element, I start scanning all the elements after that. So when I start with when this one was 0, index 0, the second scan is going to start from 1. Now when I move to the second value here, this is going to be 1. The second for loop is going to start from 2. So whatever the value of I is, the scanning that's going to be applied start from I plus 1. And that's why I do have j equal I plus 1. And again, when you're going to do the scanning, you're going to go all the way to the end, because again, the smallest value could be located at the end of that array. But here, at this line, at this moment here, you cannot get to I to equal this value here. Why is that? Because let's say here 0, 1, 2, 3, 4, 5. I have 5 elements. So if I got to the 5, to the index of let me go back here. 0, 1, 2, 3, 4, 5. So yes, if I get all the way back to the index of 5, when you're going to come here to this for loop, there is no element after that. So after this 3, there is no element. So you will have a problem here, and this array is going to cause a lot of issues and problems. So this is how it works. You're going to put size minus 1, you put size here. Now, what do we need to do? We need to update those values at the beginning. So I'm going to make some assumptions here. The first assumption that the mini is going to equal I. That's my assumption, that the smallest value is going to be located at whatever I is. So at the beginning is going to be 0, then next is going to be 1. And then, wait a minute, that's not, the mini index is going to equal I. My bad. And then the value, which is the mini, is going to equal AAR of I. That's my first assumptions. And those are going to be updated with every single iteration. Now here's what I'm going to do. Every time you find a value that is smaller than mini, then you have to update those two values. That is extremely important. So I'm going to come here and say if AAR of j, remember not I this time because we're scanning the elements, was less, I'm just going to go with less for now, with that equal, you know what, let me just change this 9 to equal 5 to avoid this issue. Again, that's acceptable, but I don't want to deal with two values that are equal the same. So ARJ is less than mini. So we found a value that is smaller than the current mini value. So what do you do in that case? Well, you have to update those two values. So I'm going to go here and type in, mini index is going to equal j because the j is the location for the smallest value, and mini is going to be updated to equal, AR of j. I found a smaller value, then the current mini value. So I am going to update it. And I'm going to keep going with this for loop. This for loop basically will, with this if statement, will lead up to update the values of the mini index and the mini value to be the second smallest value. Now, after I'm done with the scanning, there are two possibilities. The first possibility that the actual value that I had was actually the smallest value. For example, I started with 0 and 0 is the smallest value, so there's no need to do anything. That's a case. Or there's a case that I actually found a smaller value. So this is what I need to do. I need to come and check here for something. If, and this is extremely important, I double equal mini index. Well, actually, if it doesn't equal, that's what I'm supposed to check for. And let me just explain what is the meaning of if I found that after I finished this scan here that the value of I wasn't changed here at all, that basically means the smaller value that I have is the value that I have currently at index I is the smallest value, so there is no need to do any swapping. But the question is, what if I actually found a new smaller value? Well, if that's the case, we need to do a swap operation. And this is how we do the swap operation. We're going to create a, well, since I need an integer here, so let me just go ahead and do it here. Integer temp. And let's set that to 0. Okay, so here's what I'm going to do. I'm going to come here. I'm going to say temp equal, and what is the minimum value at this point? Well, let me start with this, ARR of I. So the current value is going to be stored inside temp, ARR of I, that's the value that I have. I'm going to assign it to ARR of mini index. Semicolon. And then after that, ARR of mini index will be set. The temp will set that value. I know this doesn't look really easy, but this is the easiest sort algorithm. So let's go back here. What I did here, I created those three variables. I'm going to talk about them in a sec. Now I do have a for loop. This for loop basically is going to be scanning the elements one by element. So I'm just going to scan this one, and then this one, and then this one, and then this one, and this one. I'm going to stop at 4. 3 will not be included. For this for loop, I'm going to assume that the current element that I have at index I is the smallest value, and the index I is the index of the smallest value. So at the beginning, I'm assuming that this 0 here is the smallest value. What I'm going to do after that, I'm going to scan all the elements that after this current one, looking for the smallest value. And that's what I'm doing here. As you can see here, j equal I plus 1. And then j is less than size, so it goes all the way to the end. And I'm saying here, the moment you find a value during this scan that is smaller than the mini value, which basically represents the value of the array element, update those two values. So keep going, keep going, keep going, keep going until you find the smallest value. Now, by the time I'm done with this for loop, there are two possibilities. The first possibility that I'm not doing anything about it is, what if I didn't find any smaller value? Well, if you don't find any smaller value, what does that mean? It means this one is actually the smallest one, and there's no need to do anything. You're just going to go ahead and move on to the second value. Now, if that's not the case, which is basically what I'm testing here for, index, mini index, and doesn't equal I, that basically means at the beginning I assumed that the mini index equal I, and some point it was updated, so a change happened. This is me doing swapping between the current value that I'm in with the outer for loop with the value that I found the smallest value at, the index that I found the smallest value at. So I complete this the swap operation, and I am done. Now let's go ahead and run it, and you'll see that I will get the right answer. And here we go, 1, 2, 3, 4, 5, 7, 8, exactly. And that's how sort algorithm works. Now we do have another sort algorithm, which is called bubble sort. I think bubble sort is a little bit easier. And I'm going to actually create a function for that. So bubble sort. And I'm going to pass the same two arguments. And what I'm going to do, I'm going to comment this one out. And I'm going to copy this function here. And now in the state of sort bubble, where is it? Here, let's copy this. Put it here. And let's delete everything. Well, I'm going to keep the swap because well, probably would need that. I don't think I need it. Let's just go ahead and take everything out. And if I need it, I'll just copy it. Now, again, since I commented this selection sort algorithm, now bubble sort is empty, so I'm going to end up having the same two arrays back unsorted. Okay, so how does the bubble sort works? Bubble sort works. So Control N, do not save, and let's go ahead and do this. What I'm going to do, I'm going to have this array, for example, 2, 4, 1, 3, 5, and let's put 6 here. Okay, so bubble sort basically means you scan your elements one by one. You check the element, current element, and you check the element next to it. If you found that the next element is smaller than the current element, you swap them. So you end up having 2 here and 6 here. And then you compare 6 with the next element, which is 4 in this case. And if you found that the next element is smaller than the current element, you swap them. So you put 4 here and you go 6 here. And then you compare 6 with the next element, which is 1, which is smaller. So you'll have 1 here and you get 6 here. And then you do the same thing with the 3. And then you do the same thing with 5. And you're done with the first iteration. By the time you're done with the first loop, you will have the greatest value allocated at the end of your array. Right after that, since this is the greatest value, so there's no need to include it in any operations later, so you're going to reduce the size of the array, and you're not going to include 6 anymore. And then you go on to the next element. Now you do this is what you do. 2 and 4. Well, 4 is not smaller than 4, so 4 is not smaller than 2, so you keep it as it is. And then you move to the second element, which is 1. 1 is actually smaller than 4. So what I'm going to do, I'm going to take 4 from here and then I'm going to replace 4 here. After that, you look here, you compare the 4 with the 3, and you'll see that 3 is smaller. So basically, that means you now have to swap here. So you take the 3 and you put it here. And then you update this. Oh, sorry. This is going to be 4. And then you compare 4 with 5, and there is no need to do any swapping. You stop at this point. Now, at the end of this operation, you can guarantee that 5 is the second greatest value, which is going to be in the right position. Now you do the same thing. 2 and 1. 1 is going to be moved here. 2 is going to be moved here. And then 2 and 3, nothing's going to happen. 3 and 4, nothing's going to happen. And then you're done. Right after that, you go to the next iteration and you go 1 and 2, 2 and 3. There's no need to do any swapping. And this is basically where you're going to have a flag. This flag basically is going to be rise the moment you get to a point where you're not doing any swapping. So basically, there's no need to actually reduce the size and keep going with the process because you already got it sorted. And this is basically what bubble sort is all about. Now, how do I put that in a code? Well, the idea again is not that complicated. The last one basically should be the outer loop should look like this, and the inner loop should look like this. So I equals 0, I is less than size minus 1, I plus plus, and then j equals 0, and j is always size minus I minus 1, j plus plus. What I'm doing here, very simple, just to understand, every iteration of the outside, with every single iteration from the outside loop, the size here is going to be reduced. That the inner iteration will be list by 1. And the reason why we do that, because as I said, by the time you're done with the first iteration, the greatest value is going to be set to the end. When you go to the second iteration, the second to the last is going to be set to that correct position. So you can see the size here will be reduced with every single iteration, and that's why we have size minus y minus 1. Now the idea here is very simple. All you have to do is to see if, and this is very important, look at this, ARR of j is less than, oh wait a minute, is greater than ARR of j plus 1. So what I'm saying here is the next value, where is it? For example, here, this is j and this is j plus 1. If the value of, let's go back here, if the value of the current value is greater than the value that's next to it, that basically means this is smaller than this one. So let me see, did I get this? Oh yeah, yep. So I'm doing it right. If that's the case, all I have to do is just swap between them, just like we did here. So I need to have a temp, integer temp equals 0. And I'm going to copy this just to save some time. Put it here. Now this is going to be j. This is going to be j. This is going to be j plus 1. And this is going to be j plus 1. And that's it. This is basically how it works. Now, I didn't take under consideration the flag, but let me just run it and see if it's going to work. And here we go. It worked. Now, what does the flag should do? Here's what I'm going to do. I need to have a flag here, a Boolean, let's say. Flag. I'll set that to false. And in this area here, flag will be set to false or true. Let's see if I go true now. I'll update those in a sec. So let me take this away. And here, what I'm going to do, I'm going to come here and set the flag to equal false. What does that mean? Basically means if a swap operation was performed, then the flag will be changed from true to be false. Now, before I move on into my outer for loop, this is what I need to do. I need to come see if flag break. This should simplify it. So true, and it wasn't updated. Okay. So what I'm doing here, basically, I'm going to set the flag to be true here. And then I'm going to go through the second for loop, or the inner for loop. And in this inner for loop, I'm going to do a scan. If I found myself completing this for loop and not performing a single swap operation, the original value of the flag will be true. And because it was true, that basically means no change has been applied to the flag. So I can easily break and leave the program. Now, what if I did a swap operation here one time, at least? So the flag is going to be false. And because it's false, this is not going to be true anymore. So we're going to continue. And this is me updating my bubble sort algorithm. And this should give me the exact same result. Okay. So this here is the search algorithm. This is selection sort algorithm. And this is the bubble sort algorithm. And the last part I'm going to be talking about today is multi-dimensional array. Now, the simplest form of multi-dimensional array is the two-dimensional array. Now, a two-dimensional array, you deal with two-dimensional array most of the time. Pictures are two-dimensional arrays. Those video games that doesn't have a depth, that's a two-dimensional array. Do we have more dimensions there? Yeah, we can have 3 dimensions there. We can have 4 dimensions there. We can have 100 dimensions. You can have as much dimensions as you want. You just need to know the more dimensions your array is, the heavier that array is going to be for any sort of processing. And for simplicity, today we're just going to talk about 2-dimensional arrays. Now, we know how to create an array, a simple array, the one that you see here. Okay, what I'm going to do, I'm going to copy this, put it here, and I'm going to change the name to be array 2D. Now, what is an array 2D? Well, basically, to create an array that is a 2-dimension, you need to have a pair of square brackets. Now, let me take this one out for now. Now, it's very important to specify how many rows you will have and how many columns you have. For example, I'll have 4 columns. And then for the rows, I'll have 3 rows. And here we go. So my 2-dimensional has 3 rows and 4 columns. Now, if I want to initialize this array, this is what you have to think about it. It's, as I said, 3 rows and 4 columns. Each row by itself is treated as a single dimension array. And for you to have that feeling that I have a 2-dimensional array, I'm just going to print it in this format. So this is raw 0, this is raw 2, and this is 1, and this is raw 2. Altogether is 3. Now I could come here and put 0, and put here 0, and put 0. So I'll have them all set to 0. Same rules are applied to a single dimensional array, but that's not the case. Let's just put values here. 2, 4. Let's put 5 here. I'll do the same thing here. 1, 7, 8, 9. And here I'll put 3. What am I missing here? 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 25 and 11. So here we go. This is my 2-dimensional array. Now, of course, I can take those elements, for example, and oops, no, go back. I can take those 2 elements away, and the compiler will just continue the size of the array with zeros, but that's not the case for now. So this is how you create a 2-dimensional array, as you can see here. It's basically an array of single dimensions arrays, and that's basically how it works. I can take this 3 away and it's still going to be acceptable because the compiler will be able to recognize that I have 3 arrays inside, so that's basically going to indicate that you have 3 elements here. The question is, can I do the opposite? Let's take the 4 away. Immediately you get the error. You cannot do that. So you can only do that with the number of rows, but with the number of columns, you cannot do that, because we know that if you decided that you have 4 elements here, how about the rest of the elements? You don't know how much elements you have there, so it's better to put it this way. I'm just going to put 5, so you will see that I'll get an extra zeros at the end of each one of those rows. Okay, so this is how we create an array. It's a 2-dimensional array. Now think about this. I can put your grades, for example. Each student in a row, I'll put all the quizzes there, and then I can find the average of all these quizzes for each student. Let's just imagine I do have a class that has 3 students, and those are the grades of the 3 quizzes that we have. And I want to find out what is the average of each student. Before we do that, let's just go ahead and create a function that I'm not going to create. I'm just going to show you how do I print those elements on the screen. So for integer I equals 0, I is less than 3 in this case, because that's the number of rows. I++. Of course, again, remember, you're not supposed to use magic numbers. It's better to actually create variables for those 2 values. And then I'm going to have another for loop. This time integer j equals 0, j is less than 4, and then j++. And here I'm going to go cout. And look at this. ARR 2D colon, and this is where you put I, and this is where you put the J, and I'm going to put a space between them, semicolon. Now, if I just keep it as it is, this will print them all together in one single line. What I need to do, I need to come here at the end of each row to go to the next line, so I'll have them in the form of a table. What I'm going to do, I'm going to take this one away, take this one away, take this one away, so they will look like numbers. And here we go. This is it. This is my table. If I want to process them just to find the average of each row, well, let's do that. Of course, just like you did before here, you need to have two-dimension arrays. Of course, same thing applied for 3. Can you imagine if I want to do a 3-dimension, what am I supposed to do? You're supposed to have a third square brackets. And for each one of those elements here, you need to have an array. That's how 3-dimension array works. And of course, this is how multi-dimension array works. So what I'm going to do here, I'm going to come here and type integer sum equals 0. And in this area, I'm going to say sum plus equal the array. And by the time I'm done here, it's going to go to the next, and instead of showing me the end line, this is what I want you to show me, sum divided by 4.0. Remember 4.0 because sum is an integer, and I'm just trying to make this fast. This is not the perfect way to do this. This will give me the average of each one of them, those rows. So let's see here. So this basically will give me 4.25. This is going to give me 6.25. This is going to give me 2.5. Let's see this 2.5. This is 3, 4, 5, 5, and 10. 10 divided by 4, yeah, 2.5. Okay, so as you can see, this is how we deal and treat two-dimension arrays. The last part I want to talk about here, what if I actually want to pass an array to a function? For example, this, where is it? The print. Instead of printing it this way, I'm going to create a function for it. So here, let me just copy this. I'm going to put it here. And I'm going to call it print 2D array. Okay? And I'm going to copy, I'm going to cut the body here. And I'm going to put it here. Of course, there's a lot of change that need to be applied. Let's take this one away. And I'm going to say, let's call it print 2D array. Print 2D array. I'm going to pass ARR2D here. And I'm going to pass 5. Do I need that? I need 3 and 5. Okay, 2D, okay. I made a mistake where here, by putting 4, it has to be 5. Anyway, let's just take those out, and let's take those out, and let's just look at this two-dimension array. Now, whenever you pass a two-dimension array, you need to put 2 square brackets. That will be number 1. Number 2, you need to actually put a number here, which will represent how many columns you have. In this case, it's 5. Okay, and then in this area here, you are going to pass, let's say, R integer C. And I'm going to put R here, and I'm going to put C here. And that should fix it. So this is basically, again, the only difference you can see here between this array and this array, that you're going to have to pass 2 square brackets. Now this square brackets, I didn't have to specify the number of elements, but when you pass an array to a function, you must tell me how many columns you have there. Rows is not important, but the number of columns is important. And then I'm passing 2 variables, which is the dimension of that array, and I'm using it in this for loop. Let's just run it. And here we go. Got the same exact results. No problemos. You know what? Since this is 5, it makes more sense to put this as 5, so we'll get an actual results for this. Then now the value is going to be way... Oh, yeah, because you're just adding the average. Also, I forgot that I have to include that in the average calculations here. And it's going to go way less. And here we go. Okay, so this will be the end of this video. I hope I didn't give you guys a headache. And if you have any questions, let me know in a comment or send me, yeah, just let me know. Thank you very much. Bye.